All right, so that was HOG algorithm. Any questions before we move forward?
I already asked the concatenation of the histogram. So we after we do the first computation with the four bins, four cells, then we will have a histogram of each cells that from 0 to 10 represent the nine bins, right? But when you talk about concatenated, you mentioned that it's actually just the histogram of the bin of the cell one concatenated with the cell two, cell three, cell four. But we have the same X values. Are we going to concatenate it when the X has the same values? Like, what are we going to do with the X values?
What do you mean by X values?
I mean the degrees, because for example, like in the cell one, we have um 0 to 180 degrees, right?
Mm-hmm.
But
Mm-hmm.
in the cell two, we have also another 0 to 180 degrees.
Right.
And if we concatenate them, then we will get something like 0 to 180, and then what is the x axis for the second histogram in that case? Do we just keep adding them? Now it's from 190 to 360.
No, it's for each cell, it's 0 to 180, right?
Uh-huh.
So for each cell, it will be 0 to 180. So you just can keep concatenating it. If you have two cells, you get like 0 to 180 for one, then 0 to 180 for second. Let me just try to explain that. Okay, you can see my whiteboard.
No, I cannot.
No.
Yes, we can see that now.
Okay, good. So let's say this is your block and you have four different cells. All right. Now let's talk about the first cell first. So first cell will have like 16 different pixel values, right? And for each pixel value, you have like a gradient magnitude, and then you will have orientation. Right. So let's say this is your first histogram, which is going from 0 to 8.
Shouldn't it be 180?
Okay, let's say 0 to 180. Then you have these many bins, right? Let's say the first pixel gives you magnitude of 100, and using the formula where you're distributing, it has like 30 of it goes here and 70 goes here. Then again, you have one more pixel, you have 20 more here, 10 more here.
Oh, when you mean concatenate, it's vertically, not horizontally.
No, we are not there. We are not there yet. It's just single cell. These are two different pixels of a
Oh,
cell.
okay, my bad. Okay, then
Then
10
again,
is
the third,
pixel.
yeah, another pixel. Let's say you get maybe 2 here and 4 here, something like that. So then you will get like all these numbers. You add them up. So it will, let's say, give you maybe 180. This gives you 100, and so on and so forth. Let's say 70. So this is just an array, right? Array of numbers, and the size of this, you will have how many? 9 different values. And this is coming from cell 1. Similarly, you will get 9 different values for second cell. Something like that. So that's coming from cell 2 and cell 3 and cell 4. So your final feature vector will be like a long feature vector. You just concatenate. So this is coming from your first cell. Okay, 9 different values. Then the second cell, and so on and so forth. And this will have how many? 36 different values. That's it. So you're concatenating like this.
Okay.
You get it now?
Yeah, we just ignore the axis values. Like just forget about the bins there. We don't need to keep track of the bins anymore when we concatenate.
Yeah, right. Yeah, you don't care about those anymore.
Yeah. That answers my question.
All right. I think there was one more question from Chase. So you said when it is in the exact middle of two centers, 20, we give each division half magnitude. Or does each get the full magnitude? Each will get half magnitude, right? So you don't overpay, that's your budget. So the total magnitude you have for each pixel, that's your overall budget. It's just like how you want to distribute that into different bins. And each time it might go into either single bin if it's at the center, or two different bins, depending upon how far it's from like center of those two bins. Okay, great. So that's that. So any other question before we move forward? Okay, question from K. In what case do we get 25%, 75% split? So let's say if we look into the same histogram over here, right? So these are the centers. And in this case, if you have orientation of 15, okay, let me think. That will be 5 and 15. Yeah. So if let's say if you have orientation of 15, then 75% of that will go to 10, and 25% of that will go to 30 bin. Okay, because the distance of like the center's corresponding distance has the ratio of 75% and 25%.
Yeah, I was thinking that if it fell in between 0 and 20, then we're just going at one bin.
Sorry, your audio is not clear. Can you repeat that, Kay?
I was saying, I thought if it fell between 0 and 20, then it would just go in that one bin. Why is it getting split?
No, I didn't get your question. So if the orientation, okay, let me try again. Just a minute. So the whiteboard is visible?
Yes.
Okay, great. So let me draw that actually as a horizontal line. And this is 0 degrees, this is 180 degrees. And let's say these are your bins. So again, the width is 20 degrees. And this is 10. This is 30. And this will be 50. Okay. So if you get 15 degrees orientation, then 15 will lie somewhere here, right?
Yeah, it's in between 0 and 20.
Right. It's
Isn't that
between,
one bin?
no, your bin is 10, like the center of the bin is 10, right? This is your one bin.
Oh, okay, now I get it. I was looking at the 0 to 20 on the graph there. I thought the 0 to 20 was a bin. He had 9 bins.
Okay, so these are your bins and these are the centers like 10, 30 and these. So then the ratio of this distance and this distance is, as you were saying, was this is 75% and this is 25%, right? Because this is
Okay,
5
yeah,
and
I get it. I
Okay.
thought the 0 to 20 was one bin. I didn't know 0 to 10 was.
okay, great, good. Okay, do we have more questions? Otherwise, we can move forward. All right, good. So that was HOG. Now, so rest of the, I think, lecture will cover, let's cover in the next lecture on Thursday. But any questions you have, I think I'm here to answer those.
I just want to ask the scale invariance property and other invariant property, is that regards to the objects inside of the image?
Yes, objects in your image. So as I was showing you some examples, right? The same object was smaller and it was bigger. So that's like the scale difference.
Okay. Does the corner detection also scale invariant? And if that's the case, then what's the difference between the corners and the sift?
Corner detection was not scale invariant, right? We just had that filter and we're just applying the same filter at all the locations.
But if we got a the interesting point, then
Uh-huh.
then if there's a way that we can kind of like compare the feature around the interesting point, then then that's what the SIF doing.
That's what this is doing, right?
Yeah.
And you know interesting point, but you don't know like how big that interesting point is. That's Harris corner detection, right?
Yeah, we don't have the feature or some of the other stuff.
Yeah,
Other
you don't know
important-
like
Yeah,
don't
of
know
the corner.
how to extract the features.
Yeah, that's right. That's right.
Yeah, I think there's one more question. What would be the SD of DOG in this case? I think you're saying standard deviation. It's kind of matching with the green one, right? But I think it will be slightly smaller than that. Because if you compute derivative of this curve, the first derivative, it will go something like this negative, right? And again, if you compute double derivative, yeah, it will be somewhere in between of these two. Okay. I think another question. I hope that answered your question. B, sorry, I don't know how to pronounce that, sorry. Okay, if you have a Gaussian function with sigma s, what is an appropriate first order derivative for the other Gaussian we use for computing difference of Gaussian? Okay, that's a very good question, actually, Nashir. So, and there are different ways to do that. So in this case, we are just taking the square, actually. Okay, so that's one way. You can keep doubling this standard deviation as well. And all these variations will have different effect. But that's a very good question. Okay, and that's a very interesting hyperparameter in this algorithm, actually. Okay. All right, good. Any other question you have, just drop us an email. Okay, so let's end it here. Thank you all. Bye.